Hello everyone, I'm Ayman from the University of Mauritius. So today I'll be presenting about my research study based on forecasting of global horizontal irradiance using two artificial intelligence techniques, namely ANN, Artificial Neural Network, and the second one is a hybrid model of ANN with genetic algorithm. Those two techniques were chosen due to their robust performance in the solar field. So let us now firstly understand why accurate prediction of GHI is important. So precise forecast is required since it helps stabilize the electric grid system. Precise forecast of GHI is important since it helps the provision of high-quality electrical power to the society. This will help contribute to the achievement of the Sustainable Development Goals. The main objective of this work is to extensively enhance data accuracy, optimize both models, and determine the more accurate forecasting technique. So let's now have a look at the methodology of the study. Data was collected from a PV system in Mauritius. Data such as ambient temperature, module temperature, plane of array irradiance, wind speed, and GHI were collected in intervals of 15 minutes for a whole month. So proper selection of data is a prerequisite for improved performance. In this work, we use three pre-processing techniques. Firstly, the output variable, which is GHI, was checked for stationarity, and the resulting outcome showed that the data was indeed stationary. Next, a correlational study was performed between the various input variables and GHI. Only the strongly correlated input variables were selected, since improper inputs result in high forecast errors, cost overruns, and computational complexities. Thus, all four input variables were selected for modeling and forecasting. And finally, the normalization method was also chosen since it helps condense data dimensionality, which brings about faster convergence and improved performance. Once data accuracy has been enhanced, both models were also optimized by selecting the best parameters. So once both models have been built, forecasting can then be carried out. Let me also add that post-processing is required before evaluation of the models, since it enables better interpretation of the prediction. So now let's have a look at the results. So from the graph, we can see that the hybrid ANN-GA model, which is represented by the orange lines, have higher peak errors compared to the ANN model. It is also more irregular and inconsistent in performance. To further validate the results, various statistical indicators were also used in this study. From the tabulated results, we can see that the correlation coefficient and the coefficient of determination values are much higher for the ANN model compared to the hybrid model, implying that the measured GHI values have a strong relationship with the predicted GHI values. Looking at the mean absolute error, mean absolute percentage error, mean squared error, and the root mean squared error, we can see that the error values for the ANN model are significantly lower compared to the hybrid model. So from the plot and the tabulated results, we can now confirm that the ANN model is significantly superior as opposed to the hybrid ANN-GA model for 15 minutes GHI forecasting for the month of June 2022 in Mauritius. To conclude, the main takeaway from this research is that a standalone technique can perform better than its hybrid model. Thank you.